This is the farthest human-made object ever sent from Earth. 48 years ago, we launched two small spacecraft on a journey that nobody could have imagined. Today, Voyager 1 and Voyager 2 are billions of kilometers away from us, in a dark region where even the sun's light barely reaches. But this raises a huge question. How long will they keep working? Will there come a time when their connection with us breaks forever? Or will they continue wandering through interstellar space for millions of years without stopping? Welcome to Science English. Today, we'll decode the story of the final phase of humanity's greatest mission. Let's find out where and when Voyager's journey will finally end. In deep space, where sunlight is almost non-existent, solar panels cannot work. So where do Voyager 1 and 2 get their power from? Both spacecraft carry a special nuclear battery called an RTG, or radioisotope thermoelectric generator. It uses plutonium-238. As the plutonium slowly decays, it produces a huge amount of heat, and the spacecraft convert that heat into electricity. This is the magical power source that has kept both spacecraft alive for the last 48 years. When they were launched, they had plenty of power, allowing all of their cameras and sensors to work perfectly. But nuclear power has one nature: it slowly decreases over time. Today, these machines only have a fraction of their original power left, making it harder for NASA engineers to keep them running every day. Every year, Voyager loses around 4 watts of power. It may sound small, but for a machine billions of kilometers away, every single watt matters. The situation has become so serious that Voyager no longer has enough power to run all of its instruments at once. Because of this, NASA engineers have had to make extremely difficult decisions. To save energy, NASA has shut down many non-essential systems and even some heaters over time. Space is unimaginably cold, and without heaters, these machines should have frozen long ago. But surprisingly, despite the freezing temperatures, Voyager's parts are still working. It's nothing short of a miracle that technology built in the 1970s is still surviving in 2026 on the most dangerous paths of space. But the biggest question is, how long will this power last? Voyager 1 has traveled so far away from us that communicating with it now feels almost like a miracle. Right now, it is more than 24 billion kilometers away from Earth. Imagine this: if we send a signal today, it takes more than 23 hours just to reach Voyager, and another 23 hours for the reply to come back. That means NASA scientists must wait almost 2 full days just to receive the answer to a simple hello. These are the kinds of distances found in interstellar space, distances that even our fastest machines can barely comprehend. Signals coming from that far away become unbelievably weak. By the time Voyager's data reaches Earth, its power is billions of times weaker than the light of a refrigerator bulb. To hear this faint whisper, NASA uses the Deep Space Network, a worldwide network of giant antennas located in California, Spain, and Australia. These massive dishes stay pointed toward space 24 hours a day to catch Voyager's weak heartbeat. Without this network, Voyager would have disappeared from our reach long ago. One of the biggest challenges is that Voyager's computer memory is only 68 kilobytes, smaller than a single photo on your phone. Controlling this 1970s machine with today's supercomputers is extremely difficult. Whenever Voyager develops a problem, engineers have to dig through old papers and hand-drawn diagrams just to understand its systems. It's like trying to repair a vintage car while it's traveling through space, with the fear that it could fail at any moment. Yet somehow, it keeps moving forward. Now let's talk about the moment everyone fears: the moment Voyager finally goes silent forever. NASA scientists estimate that between 2025 and 2030, its nuclear battery will become too weak to power even a single scientific instrument. Even now, many of Voyager's cameras and sensors were shut down years ago just to keep the radio system alive. But even this strategy won't work forever. The decay of plutonium is a natural process that cannot be stopped. As the plutonium weakens further, Voyager will eventually lose the energy needed to keep its antenna pointed toward Earth. And once its radio transmitter shuts down, it will go silent forever. Scientists believe that around 2030, Voyager will become a ghost ship of space. It will continue floating through the cosmos, but we will never again be able to hear or see it. That will be the moment when humanity's longest-running and farthest-traveling mission officially ends. We will have no way of knowing where it is anymore. But silence does not mean the journey ends. Even if its radio dies, Voyager's speed and direction will keep carrying it forward. Without engines, it will continue traveling only because of the momentum it already has. Once its connection with Earth breaks, it will become a permanent traveler of our galaxy. This silent machine will remain as proof of our existence, wandering through the darkness of space for millions of years where perhaps nobody else will ever reach. It may become a legacy that survives even after humanity itself is gone. Voyager 1 and 2 are not just scientific machines, they are floating time capsules of humanity. When they were launched, under the leadership of famous astronomer Carl Sagan, a very special object was sent along with them, the Voyager Golden Record. It is a 12-inch gold-plated copper disc containing memories of Earth. The purpose was simple. If intelligent alien life ever found these spacecraft millions of years in the future, they would know that somewhere in the universe, a species called humans once existed. The record contains 115 images of Earth, greetings in 55 languages, and many sounds from our planet. It includes ocean waves, thunder, birds singing, and even the sound of a mother kissing her child. And for India, there is a special moment of pride. The record also contains Indian classical music, including Jat Kahan Ho, sung by Kesarbai Kirkar. The Golden Record is like a message in a bottle thrown into the cosmic ocean with the hope that someday someone might find it. The spacecraft also carry a needle and instructions for playing the record, written entirely in scientific symbols so that any advanced civilization could understand them. Most importantly, this gold-plated disc may survive the harsh environment of space for at least 1 billion years. Even after Voyager itself becomes nothing more than a dead piece of metal, the Golden Record may continue floating through darkness for millions of years as proof that humanity once existed. In 2012, Voyager 1 made history when it crossed the heliopause. This is the boundary where the sun's magnetic field and solar winds end, and true interstellar space begins. Voyager 1 became the first human-made object to cross this boundary, and in 2018, Voyager 2 followed it. Today, both spacecraft are in a region beyond the sun's influence, traveling through the empty space between stars. Voyager showed us for the first time what the environment outside the sun's protective bubble actually looks like. Without these machines, humanity would never have known how dangerous and enormous the real cosmic wilderness beyond our solar system truly is. However, technically speaking, they still haven't fully left the solar system. The true boundary is believed to end at the Oort cloud, a giant sphere made of billions of icy objects surrounding the sun. Voyager 1 will take hundreds more years just to reach the inner part of the Oort cloud, and thousands of years to fully cross it. So even though these spacecraft are unimaginably far away, they are still technically part of the sun's family, slowly moving toward freedom. The year 2026 is expected to become historic for this mission. By November 2026, Voyager 1 will cross the magical distance of 1 light day from Earth. That means any radio signal we send will take a full 24 hours just to reach it, and 2 full days for a reply. At a distance of around 26 billion kilometers, even our sun would appear as just another bright star. Right now, in May 2026, NASA engineers are doing everything possible to keep this old machine alive. Because of severe power shortages, another important instrument called LECP was permanently shut down in April 2026 so that enough power could remain for the data transmitter. At this point, only 2 scientific instruments on Voyager 1 are still functioning. Engineers are now working on a new energy-saving plan called Big Bang, hoping it will allow this silent traveler to continue sending data until around 2030. Now the question is, will Voyager ever reach another star? At the moment, it is not heading directly toward any particular star. But around 40,000 years from now, Voyager 1 will pass near a star called Gliese 445. It won't pass extremely close, but it will travel within about 1.6 light-years of it, which is considered relatively close in space terms. Meanwhile, Voyager 2 will pass near the star Ross 248 roughly 42,000 years from now. These encounters remind us that our tiny messenger is now traveling across the enormous map of the galaxy, where distances are measured in light-years. These spacecraft are not wandering randomly. They are carving their own paths between the stars. Over millions of years, they may pass near many different star systems, even if humanity is no longer around to track them. Once Voyager completely leaves the solar system, it will begin orbiting the center of the Milky Way, just like our sun does. These silent machines may continue circling the galaxy for billions of years. Scientists believe it could take millions of years for them to complete a single orbit around the galaxy. They will become permanent satellites of the Milky Way, endlessly traveling among the stars. And perhaps one day, Voyager may even pass near the region where our solar system once existed. It's incredible to think that this tiny mark of humanity may still survive long after our sun becomes a red giant. Voyager's journey is no longer just a mission, it has become part of the endless cycle of cosmic time itself, a silent citizen of the galaxy that may carry humanity's identity for billions of years.